Okay, close your eyes for just a second. Imagine the car of tomorrow.
Mm-hmm.
Now, what if the engine, the heart of the car, wasn't under the hood?
Right.
What if it wasn't anywhere traditional, but actually inside the wheel itself?
Yeah, it's pretty radical thoughts.
Exactly.
Yeah.
What kind of fundamental shift could that mean for how cars are designed, how they drive, how they even feel?
It changes almost everything.
Well, today, that's exactly what we're diving deep into, this groundbreaking world of in-wheel motors. And we're really going to focus on some truly transformative innovation from Protean Electric, specifically their latest development, the Gen5.
And it's such an exciting area because, look, this isn't just some sci-fi concept stuck in a lab somewhere.
Right, not just theory.
No, not at all. In-wheel motor technology is, well, it's developing really fast. It's a solution that promises some really significant advantages.
For who specifically?
Well, obviously for the manufacturers building the cars, but also, importantly for you, the person who might be driving one soon. It's about completely rethinking how you build a vehicle,
Yeah.
right from the basic architecture.
So our mission for this deep dive today is basically to give you a shortcut, a way to get really well informed about this, frankly, pretty exciting automotive frontier.
Yep.
We'll unpack what in-wheel motors, or IWMs, actually are. We'll dig into their main technical advantages.
Yeah.
And then we'll look at how Protean Electric is taking this really clever idea and turning it into a fully industrialized, ready-to-go product with their Gen 5.
And crucially, how it all connects back.
Exactly. What does this massive shift mean for the kinds of cars you might be driving, owning, maybe even experiencing in the next few years?
Okay, let's do it.
So let's start right at the beginning. What exactly is an in-wheel motor, an IWM?
Right.
Because when you think of a normal car, you picture like a central engine, right? And then all the complicated bits, drive shafts, differentials, sending power to the wheels.
The traditional drivetrain, yeah.
Yeah.
A lot of components.
But with an IWM, that whole setup is just gone.
Poof, vanished.
Instead, you have an electric motor built right into the hub of the wheel.
Mm-hmm. Integrated directly.
Think about that. Each wheel basically becomes its own independent power source, its own little powertrain unit. It's a totally different way to think about making a car move.
And here's where it gets really interesting, like straight away. Protean Electric's Pd18 Gen5 motor. It's not just neat packaging. It delivers some seriously impressive performance figures.
Okay, like what?
We're talking about peak torque, the twisting force of 1,500 Newton meters. Industry-leading stuff.
1,500 from inside a wheel.
Yes, all achieved within an 18-inch wheel rim. Now, to give you a sense of that, that kind of power, from such a tiny space, it's truly remarkable.
More than you'd expect, I guess.
Oh, way more. There's actually more force than you'd get from some, big traditional V12 bi-turbo engines.
Wow.
And look, if you find these kinds of enriching details as genuinely exciting as I do, well, you are definitely in for a treat today.
Huh. Okay, noted. So this compact motor packs a bigger punch than some massive V12s. But what does all that power actually do for the car, besides just making it go fast?
Right. It's not just about 0 to 60 times.
Protean talks about 3 main technical advantages with these IWMs. What are they?
Yeah, they focus on 3 key areas. First, big gains in overall efficiency. Second, much smarter use of space inside the vehicle. And third, a really enhanced driving experience. And these aren't just, bullet points on a spec sheet.
No, they have real consequences.
Exactly. They translate into a much bigger value proposition for the car makers.
Yeah.
Lets them build better, more innovative cars. And at the end of the day, that means a better, more capable, maybe even more affordable car for you, the customer.
Okay, let's really dig into those advantages then, because this is where it gets really interesting for everyday use. Let's start with space efficiency.
Good place to start.
When you stick the motor right in the wheel, what's the most obvious benefit for car designers? Is it just about cramming things in, or does it change how they approach the whole interior layout?
Oh, it's a total paradigm shift for them. Instantly, you delete what engineers call the drivetrain tunnel.
That hump in the middle of the car.
Exactly. That bulky spine running down the car, usually housing the transmission, the drive shafts, all that mechanical stuff. Getting rid of it isn't just about removing parts. It fundamentally frees vehicle design from being dictated by that big central mechanical lump.
Okay, so what does that mean for, say, your next car, if that tunnel's gone?
Well, it frees up a massive amount of space. I mean,
Yeah.
really try to visualize this. The outside size of the car, the footprint, stays the same.
Right.
But inside, you suddenly have way more usable area for people, for luggage, whatever.
So you could have, what, A completely flat floor?
A completely flat floor, yeah.
Hmm.
Imagine how much more legroom that gives rear passengers. Or maybe you use that space for a huge cargo area. It makes the
Wow.
car way more versatile.
The design possibilities must just explode. Like totally new cabin layouts become possible.
Absolutely. Designers can really start thinking about making the inside of the car truly centered around the people using it, not around the mechanics.
Okay, space is one big plus. How does this link to the second point, the enhanced driving experience?
Well, that freedom flows right into it. Because each wheel has its own motor, you get incredibly precise individual control over how much power goes to each specific tire.
Right, independent control.
Exactly. Which raises the question, how does controlling each wheel's traction independently actually improve things like handling or dynamics or even safety?
Yeah, how does it?
It means you can have extremely nuanced power delivery. Think about cornering. You can use something called torque vectoring, where the car precisely adjusts the power to each wheel to maximize grip and help pull you smoothly through the turn.
Ah, so it actively helps you corner better.
Precisely. Or imagine driving on a slippery road. Each wheel can instantly adjust its power completely independently to find the best possible traction and keep the car stable. It's way beyond what old-school mechanical systems can manage. It makes the car feel much more intelligent, much more responsive.
Okay, so better use of space, much finer control. What's the third big advantage? You mentioned efficiency.
Right, efficiency. And this is a really compelling one for automakers, especially with EVs. How does moving the motor into the wheel actually save energy for the whole vehicle?
Yeah, how does that work?
Well, by putting the motor right at the wheel, you eliminate a whole lot of mechanical losses you get in traditional drivetrains,
Losses. Like what?
like friction in the gearbox, in the drive shafts, in the differentials. All those spinning parts waste energy just turning each other,
Ah, okay. Less plumbing, less waste.
pretty much. Protean's solution, by dramatically simplifying that whole drivetrain, leads to a real measurable reduction in how much energy the vehicle uses overall.
And for you, the driver, that greater efficiency means
What?
longer range.
Potentially, yes. Longer range for your EV on a single charge. Or if you're thinking about, say, delivery vans or trucks, it means lower running costs for the companies operating those fleets.
Which eventually helps everyone, right? Lower energy use, maybe lower maintenance costs too.
Exactly. It's just a smarter way to engineer the system, leading to real-world benefits.
Okay, so this technology sounds amazing on paper, but you said it's not just theory anymore. Protean Electric is actually building these things now.
Oh, yeah, absolutely. They are actively industrializing it. They've brought their Protean Drive Generation 5, the Gen 5 Pd18, to full production. This isn't a prototype anymore. It's a commercial product you can actually buy and use.
Wow. And getting there must have been quite a journey. How do you even test something like this?
Well, that's what's really fascinating here, the sheer amount of testing they did. They didn't just test one or two units. They took over 80 of these Pd18 Gen 5 motors.
80.
80. And put them through 64 distinct test programs. 64.
That sounds intense.
It was brutal. Basically a gauntlet designed to simulate every horrible thing a car wheel might encounter over its entire life. Potholes, water, heat, cold, vibration, everything.
Why so much testing?
To make absolutely sure it meets all the relevant laws, regulations, and crucially, the incredibly strict standards set by the car manufacturers themselves, the OEMs. This product is built on, get this, over 15 years of engineering work.
15 years.
And a combined total of 700 person-years of development specifically focused on in-wheel motors. That's a huge amount of knowledge and effort poured into this.
What's tough?
Extremely tough. The design itself is robust. It's engineered to meet a target of 15 years or 300,000 kilometers of durability.
300,000 kilometers.
Yep. It can handle things like driving through deep water, hitting massive potholes, and dealing with really harsh environmental conditions, from scorching heat to freezing cold.
Okay, but here's something interesting. You mentioned safety validation. ISO 26262, ISELF-LD. That sounds serious.
It is serious. And it's actually an industry first for in-wheel motors. It's been validated to ISO 26262 as something called a safety element out of context, addressing ASIL-D level hazards.
Okay, translate that for me. ASIL-D.
ASIL-D is the highest level of automotive safety integrity. Think critical systems, like airbags or braking systems. It means Protean has engineered these motors to meet that absolute top tier of safety standards.
Like aircraft level safety.
Essentially, yes, ensuring the vehicle stays safe and controllable even if something unexpected happens. And the safety element out of context part means the motor itself, as a component, is certified to this standard.
Ah, So car makers can trust it more easily.
Exactly. It makes it much easier for any manufacturer to integrate it into their vehicle safety systems confidently. As Stephen Lambert, Protean's CTO, put it, and it's a great quote he called IWM's a pivotal enabling technology for the next generation of EVs, and stressed how vital that robust testing and validation framework is.
They definitely seem to have covered the testing bases. But back to that durability number of 15 years, 300,000 kilometers. For someone just driving their car day to day, what does that actually mean? Is my wheel motor going to suddenly die at 300,001 kilometers?
No, definitely not. It's not like a timer runs out. Think of it more as the design for life under typical driving conditions.
Okay.
They've rigorously tested it to make sure it can endure years and years of normal driving, hitting potholes, temperature swings, constant use without failing. It means they've validated the motor against severe shocks, vibrations, heat cycles, sand, dust, water, even chemical contaminants,
Right.
to ensure it's reliable and robust over that long period and high mileage. So it's really a statement about its built-in long-term dependability under realistic conditions, not some hard stop date.
Got it. So designed for the long haul, and you said they're actually making these now.
Yes, production kicked off in the third quarter of 2023. They have a state-of-the-art factory in Tianjin, China.
And is it like automotive grade?
Oh, yes. The facility has IATF 16949 certification. That's the global standard for automotive quality management. It's basically a stamp saying their factory produces parts with the same quality and consistency you'd expect from any major car brand.
So this really is the start of large-scale production.
It marks the beginning of large-scale industrialization for this tech. Absolutely. And they've designed it smartly, too. It's modular. They have 400-volt versions available now, and they're expecting 800-volt versions to be ready by the end of 2024, which is important for newer EV architectures.
Are we seeing these in actual vehicles yet, or is it still mostly for future projects?
No, they're already out there working, which is really exciting to see. For example, a company called BBEO is using them in their Reborn Electric retrofit solution.
What's that?
They basically take classic vehicles like old Land Rovers and convert them into modern EVs using these Protean motors.
Cool. Any other examples?
Yeah, another one is ConMet. They're using a version for their Preset Plus electric hub system. This is for zero-emission refrigerated trailers, big trucks.
Wow, so from classic cars to heavy-duty trucking, that shows some versatility.
Definitely. It really highlights how adaptable the technology is. Andrew Whitehead, Protean CEO, really summed it up well. He calls IWMs a critical component to the future of the electric vehicle industry.
Why critical?
Because, he says, it allows manufacturers to finally adopt in-wheel motors at scale and at an affordable price. And crucially, use them to genuinely differentiate their vehicles in what's becoming a very crowded EV market.
Okay, so we've gone through the tech, the advantages, the fact that it's actually being built and used now. Let's bring it all together. What does this all mean for you listening now and for the wider car industry? What's the big so what here?
Well, for the car manufacturers, it's potentially a huge win. This technology lets them achieve similar, maybe even slightly lower, production costs for their vehicles.
Lower costs, even with this advanced tech.
Potentially, yeah, when you factor in removing all the traditional drivetrain parts. But here's the key. They get those costs while offering a much greater value proposition to the customer.
Right, all those benefits we talked about, space, handling, efficiency.
Exactly. More interior space, better handling, better safety, higher efficiency, all potentially for the same or even less manufacturing cost. So what does that let them do?
Sell more cars, make more profit.
Either or both. They can gain market share by offering a clearly superior product, or they can improve their profit margins. It's why you're going to see more and more manufacturers looking seriously at large-scale adoption as the tech matures and the costs keep coming down. It fundamentally changes the economics of building an EV.
And flip that around, what about for me, the person buying the car?
For you, the driver, this directly translates into seeing potentially better quality electric vehicles hitting the market, maybe at more convenient, more accessible prices.
Better and potentially cheaper.
That's the promise. In-wheel motors contribute to EVs that are lighter, more agile, offering real economic advantages, not just when you buy them, but also in daily use, because of that better efficiency, that longer range.
So it's smarter tech that gets rid of complex, heavy stuff.
Precisely, leading to better efficiency, better durability, and frankly, just a more enjoyable driving experience overall. Imagine hopping into a car where the inside just feels way bigger than it should.
Yeah.
Where taking a corner feels incredibly smooth and controlled, and where your battery charge just seems to last longer. That's really the tangible promise of in-wheel motors becoming mainstream.
So wrapping this up, it really feels like in-wheel motors, especially with what Protean Electric is doing with their Gen 5, aren't just a small step. They're a significant leap.
Oh, absolutely. It's transformative,
Yeah.
moving from a cool concept to actual industrial scale production.
Yeah.
The potential for vehicle design, performance, efficiency, it's huge.
Okay, so here's a final thought for you to chew on as we finish. If the drivetrain isn't this big central thing anymore,
Mm.
and each wheel is essentially its own independent unit, what totally new kinds of cars could this enable? Think beyond just extra legroom.
Yeah, what weird shapes could cars take?
Yeah. Could we see vehicles that maybe change shape depending on what you need them for? Or that can maneuver in ways we haven't even thought of yet? How could this fundamentally change how you drive, how you own a car in the years ahead? What possibilities open up when you free the wheels, so to speak?
It's a fascinating question. And look, we absolutely love diving deep into these kinds of topics, uncovering these, well, surprising facts and trying to connect the dots for you. There's always more to learn, always more to discover.
Definitely.
So to make sure you don't miss out on any of our future explorations and you stay ahead of the curve on cool stuff like this, please do be sure to follow our channel. We'll have more insights and, yes, more surprising facts coming your way.